I get a lot of bright and silly ideas, and I tend to bring the silly ones to life. I guess it's a nice distraction from my daily job. The cookie launcher I made for Christmas was one of those ideas. Maybe not the most practical thing in the world, but definitely an icebreaker around the coffee table. I got a lot of requests to share the project, so I decided to make a simpler version. Well, as you can see, it got out of hand and ended up even more complicated. Even if you don't like cookies or just don't want to build it, I hope it inspires you to bring your own ideas to life, and maybe you pick up some new knowledge along the way. Cookie! This version has a lot of improvements, and the most obvious one is the acrylic glass box. Of course, we need to show off the beautiful mechanism inside. Okay, before you arrest me, these are not real cookies, those are 3D printed. I just could not stand getting all those crumbles all over the place. I'll share them as well for you, but please don't eat them. Another big improvement was removing all the wires going to the lid, as it made the reloading a real pain in the ass. So I moved the batteries and the power switch to the bottom of the box and came up with a rocket science-worthy new hatch design. Now the lid is completely free of wires. The old button tasted a bit like 1987, so I made a new one with built-in LEDs that brings us at least up to 1998. And of course, you can choose whatever button name you prefer. The magazine is now easier to build, though still full of fun little parts to click into place. I almost forgot to mention the new cookie guide servo. Look at this slow-mo from the old launcher. Look how the tilted cookie slams into the top bar and how it causes the cookie to flip around during flight. To make the cookie launch straight up and most likely gain more height, I added the RC servo with a sliding guide mounted. This straightens up the cookie and guides it through the launch. Another added feature is the RGB LED strip. This is very optional of course, but it adds an awesome effect to your late night cookie parties. We all eat cookies all year long, so I moved away from the Christmas theme. The gingerbread cookies are now replaced by these cookies. Really only because they are cheap and they don't crumble that much. I designed the launcher in Fusion 360 and you will find links to the files in the description. All parts are 3D printed both in PETG and PLA. In addition, I will share wiring diagram, code and bill of materials. Now let's take a look at how this machine is built and works. So this makes up the very heart of the machine. The tab inside the big gear will drag the center arm down. This will stretch the rubber bands and make it ready for launch. When someone presses the button, the motor is started again, and this pushes the arm over lower dead point and the cookie launches. Then the process simply repeats. One of my best electronic tricks is to mate a DC-DC voltage regulator with a Xiao microcontroller. The DC-DC brings the battery voltage down to a clean and steady 5V, which I use for both the microcontroller and the RC servos. The Xiao is the brain of the machine, and I program it with Arduino. I've used this solution for many projects now, and it works great. The DRV8833 motor driver is great for this project. It's small and can drive 2 DC motors. I just solder it directly to the Xiao with some headers. Notice that I don't connect the sleep pin, as I needed the Xiao pin for the RGB LED strip. Make sure to wire the sleep pin to 5V as shown in the wiring diagram. Driving these DC motors from code is dead simple. The driver has 2 inputs for each motor. If you set one of the 2 pins high, leaving the other low, the motor will spin in one direction. If you do the opposite, motor shifts direction. So in the code you just define the pins for motor control and write them accordingly. This example code will change motor direction with 2 seconds interval. So don't worry about polarity when soldering on the motor wires. You simply set direction in the software after the build. For the launch button with integrated LEDs, I use a servo cable to transfer ground, LED signal and button signal. I recommend to solder on as many wires as you can before mounting it on the launcher. I also solder on a common ground wire to use later on for various grounds. It's just a lot easier to join a bunch of wires together than trying to solder multiple wires onto the same ground pad on the electronics. Controlling RC servos from a microcontroller is very easy when using Arduino. You just include the servo library, define the pins connected to the servos, make an object instance for each servo, and initialize them. Now you may write a value between 0 and 180 degrees to make the servo move to that angle. As you see, this code will loop between 0, 90 and 180 degrees. I will share this calibration code that you may use to connect and calibrate the servos. The button will toggle between open and closed positions on both servos. I use optical end-stop switches for both stopping the main launch slider and the magazine. These are great as there is no mechanical elements in them, just a beam of infrared light across. When the beam is blocked, the signal shifts. Notice that I powered these from the Xiao 3.3 voltage pin, as the Xiao only tolerates 3.3 volt signals. And here I join the grounds from the different components together. Working with acrylic glass was a new experience for me, and I'm really happy with how it turned out. To cut the glass, simply cut multiple times with a knife before you convince it to snap at the cut. Now, bending the glass turned out a bit more tricky. However, once I started bending before cutting to size, I managed to get decent bends. Now this thing is not very fast when it comes to reload, but think positive about it, it makes your cookies last a bit longer. I will share the main code as a starting point, but I recommend playing around with it to get your personal touch on how the machine operates. For me that's the most fun part of the whole project. Thanks for watching.